Good afternoon. Today, I'm going to cover a little bit more about energy, which is what all these other episodes have been about. I've been trying to follow the process of the transformation of energy throughout the different levels of understanding. We started out with physics, with quantum physics. Last episode, I went through chemistry and biology quickly. The form of energy changes, but I got a question from in one of the comments about what energy was. And so I need to go back to my basic physics roots and say, well, F equals ma, E equals mc squared. Energy is mass accelerated, right? So we can put that down as joules as a form of measurement. However, it's the movement, it's the acceleration of something. It's taking away that inertia and making it kinetic. Okay, that's energy that we understand in physics and engineering, the things that we study to try and figure out how things work. And so we've seen energy explained in different ways in different aspects. For example, in biology, well, not biology, but in nutrition, we consider energy to be sugars and carbohydrates and the things that your cells need to feed for them to move, for them to burn. We also have, for example, in physics, we can start off the basic area is wavelengths. That's the only differentiation between one form of energy and another, because we can have light energy, we can have gamma radiation, we can have X rays, we can have ultraviolet, we can have infrared, heat being infrared as well. So those are different levels or different forms of energy. They're all wavelengths, they're all energy. All of them are energy. They just have a different focal point and they have different effects and different potencies. For example, gamma radiation is a lot more aggressive to things than what X rays, which are more aggressive than ultraviolet rays, which are more aggressive than regular uh, spectrum light that we see that we know as colors and that sort of thing. All these things are different forms of energy, but they're all energy. It's the wavelengths, it's the movement, it's the acceleration. And what I've been trying to explain throughout this entire process, and evidently it wasn't that clear, is that the way that we perceive energy in those in the different environments. For example, we're not going to be talking about wavelengths in chemistry. I kind of do because we're talking a lot about electrons in chemistry, the bonds and the chemical bonds, and then the interactions that they possibly have. And so we have different attributes, different metals, different gases, noble gases, and then you've got your metals columns, and then you've got your radioactive, unstable, and everything else. So the electrons affect the interactions and the molecules they create have different forms of interactions with other things. But I would associate with the energy there as being the electrons, because that's where the majority of the bonds occur. That's where the majority of the energy is transferred between them. Besides, whenever you've got the break apart of moles and you're actually breaking apart different things and find out what the components are, that's a lot deeper. Didn't want to get into that, but at the same time, that energy is also related in neutrinos and different things that were heat energy that's going to be released. Different forms of energy that will compensate the lack of mass between the two articles that we're starting. In biology, we see it as the food. It's heat. It's the we got to heat up our bodies naturally. That's what mammals are versus reptiles. Reptiles use the sun to heat up their bodies. However, we have an internal heating system. In order to generate that heat, we have to feed our body. We have to produce that energy internally. That means that we eat more things, more sugars, more carbohydrates, more proteins, more meats, and that sort of thing. Not forgetting the vitamins, minerals, and everything else that we need for our body to build and prepare for different adversities, like diseases and going up a mountain or playing soccer or swimming in the ocean. Each one of those is going to have a different requirement from your body, and it's best to be prepared for all of it. But that's not necessarily the energy aspect that I was wanting to talk about. It's more the infrastructure. But the energy is the food that you consume that you actually burn off or transfer to your cells to burn off and use through the bloodstream. And so at that particular point, we see that the energy is being transferred through the blood to other areas. Well, that's also energy. Those little molecules of oxygen that are being taken to the cells because they use that to be able to make the production. That's also energy being carried to them. What today in our modern society, we see energy as diesel fuel or oil or gasoline. That's also energy. It's turned into combustion. It's burned, and the heat, moves things, and it's the heat that's created. They're just different forms of energy. So, what is energy? Um, Everything, as far as what Nikola Tesla mentioned. So everything is energy in one form or another. How we see that energy depends on our perspective and our focus and what it is that we're actually talking about. So, for example, I'm still lacking in sociology and economics, which in these videos I haven't gotten to, but that's one of my objectives, is to make all of this understanding of how things work and how they build together, and how those energies are transformed, and the most beneficial way of being able to use those energies going forward and transforming through the systems, and understand that they're deeper than just the sugars or solar radiation or fuels that our cars or jet planes or our bodies consume. Energy is a lot more. Our consciousness generates certain levels of radiation that can be felt and measured. In fact, for decades they've been doing that, taking pictures of your aura and all that kind of stuff. So whether people believe it or not, well, yes, our bodies emanate. We're always emanating heat at all times, so we're radiating energy in that form. We're also emitting pheromones and different smells, which is also a type of energy that's being let off while it has a reaction to something else. If you have BO, the reaction is people are going to go away. If you like to wear cologne, the reaction is people might actually be more interested in what you have to say. Those are different forms of energy, but they're also influence. Okay, they make things happen, which is another way of looking at energy. A cell needs to have that energy in order to move forward, to grow, to expand. And in the same way, a society or an economy needs those kinds of energies to make things grow and expand. One of the things that kind of frustrated me about economics, for example, is that, yeah, it has a certain level of mathematics and we like to see it as a science, but in the end, it depends on the perspective of the purchasing class. Who's going to be buying that object, that material, that product? Do they feel a need? Okay, fine. Do they have the ability to pay for it? Fine. But there are so many options. Which one do they choose? And at that point, it starts to break down into individual preferences. And this is the style at this point. No, over here, this is another style. Yeah, but we're in a bear market, so we need to get into things that give us some kind of payback of some monthly or semestral stipends and that sort of thing. Others are going, yeah, but we're in a growth market, so those are usually cheaper stocks. Let's get away from the monthly, income and get into something that high growth potential and everything else. And so their emotions and the way that they're looking at the world affects the way that they invest their money into economics. And so economics ends up being very, very emotionally based. It's sociologically based. It's psychologically based. And so all these are also energies, because if you can motivate people to do things, that influence that you have on somebody makes something else happen. And so in some aspects, you can consider that as energy as well. The simple fact of speaking is another form of energy. So you're pouring that, you're only moving air molecules. It's not a lot of energy. However, the impact that that energy has on the other side that receives it and understands those messages can actually change. So that can also be considered energy in some perspectives. Those wavelengths, electrons, charges, sugars, heat, electricity, movement, influence, means of production. Energy is also our capacity. Capital, money. Money is also considered a form of energy. Money makes things move and things, because that is captured energy. The work that someone has done, the energy they put into a project is reward to them with other energy? No, with something that references the energy that was put into it. And so money is a stored reference of energy that you can then, you spent it there, so you got it back, so you can spend it on you using less energy here. You're not going to have to bake bread or grow the wheat. You can pay the energy of somebody else growing the wheat and making the bread, and the whole process in between, for some of the labor that you put in. Now, is that equivalent? Are they fair? That's a whole nother topic we're not going to get into right now. But all of those are different perspectives and forms of energy. So, Pasqual, I hope this kind of answered your question. And I welcome questions from others as well. Other perspectives, hey, I'm open. That's what science is, after all. It is questioning everything and trying to find a reality, something that stands up to all the questions. Okay, no, I'm not there yet, but hey, um, we're always on a constant journey, are we not? So, thank you very much for your patience today. Yeah, 10 minutes more than what I wanted, but thank you, and I'll see you next time.